Hello, Mental Growth Network, and welcome to a new podcast for a very special and very interesting topic nowadays for many people. And the topic is AI and the brain. And to discuss this topic, I want to invite Devin Özbağcı, data scientist and doctor in neuroscience. Welcome.
Thank you. Thank you. I'm happy to talk about this topic with you and your network.
So before we will start, can you just describe a bit your profile? What means doctor in neuroscience and sometimes AI data science expert? How did you manage to have this whole big, very hard professions in one person? And please tell us your story.
So, yeah, I will tell you the short version. So the Doctor of Neuroscience part, I did my PhD in cognitive neuroscience. I was studying decision making specifically. And after I completed my doctorate studies, I decided to move into AI and apply both my data science and analytical skills there, and also look at the intelligence from a different point of view. So in the end, actually, it happens to many PhDs. That's because the positions in the academia are limited, and also always the topics that you study are limited by the funding agencies. Many of us end up in private companies. So right now I'm working at a local AI company in Barcelona. Yeah.
Amazing, amazing. And nowadays you work directly with AI, and what are you doing? You're programming or you doing some research? Can you tell us more? Maybe it can be also interesting a bit to share the AI experience.
Mm-hmm. So yeah, I work for client projects actually. So I work on voice assistants and their models, their language models. So day to day, my job involves like measuring performance of certain models, updating data, and trying to fix bugs. So it involves both programming, but also more like the knowledge of AI is highly useful. It's not like a developer job, obviously. So it's this unique niche spot that requires both like linguistic information and also knowledge of machine learning.
Thank you. Before we will go deep, I want to ask you to tell us about this association. A lot of people associate AI with some kind of a brain. So
Yeah.
from the neuroscience point of view, can you please explain us what is this connection? Is there any really connection about that or
Yeah.
not? Why people so often associate it?
Historically, this association makes total sense because how AI is actually started to be thought of was with its similarities with natural intelligence and brain. So, for instance, with the more research has been done in how the brain works, how a neuron works, these findings have influenced highly the algorithms developed to build the first versions of AI systems. So it makes sense because, and also right now when we use a chat gpt or a certain llm ai tool right now, it feels like there is like a sentient being on the other side. And that's why also it makes sense that people always compare this, like how similar this is to ai, etc. And of course, there are certain differences as well. But historically, yes, brain research has influenced AI, and also AI is influencing the brain research and our understanding of intelligence right now.
And then what about the differences? What are the
Mhm.
differences between our intelligence and AI intelligence?
First of all, when we think of humans or animals, the intelligence that they have is in a body, it's in context with a body. It's a living being that interacts with the outside world. But it's not exactly like that with the artificial systems. So they are, instead of learning through a lifetime, they are programmed or trained specifically with certain data. So this creates a big difference. For instance, you can, yeah, to And also one of the other big differences, many of the humans, like even a toddler, can learn from one example. But most of the artificial AI like systems, they need tons of data. And they can be great at, for instance, playing chess or like finding patterns in a fMRI image. But learning from one mistake of learning from one example of rotten fruit, it is still like humans and animals are better. So yes, these there are these differences, and also another facet is how we see human intelligence, because we are not only intelligent, but we are also conscious. We have emotions, we have empathy. So these kind of concepts are hard to attribute to AI. So that is also a big difference. Like if an intelligent being is not conscious, how it sounds different. Like, these are all deep philosophical debates as well, but in general, yes, we are not sure right now, for instance, if these big LLM models uh, have the same representation of the world. For instance, when we say high mountain, we think of our uh, physical associations with it. Yes, I would get tired. Yes, it would require my muscles to climb there. Like it represents all sorts of these sensory motor interactions as well. However, for an LLM model, it is just a text that it got trained, and it in a vector embedding space. So it does not have the same outside associations as our thinking.
Mm-hmm. Yes, interesting. And can we now connect this neuroscience and AI? I'm just interested more for professionals in this field because a lot of our audience are already established doctors,
Yeah.
and a lot of people now they study neuroscience, even if they are not have their PhD in neuroscience or master, but still this kind of topic which is now very popular in medical industry because people understand that it affects so many things related to health issues.
Mm-hmm.
So my question for you will be, how does AI affect brain research, and opposite thing, how the brain research affects AI? Is there any connection directly with neuroscience and AI? And can you tell us more what is nowadays the
Totally.
usage of AI in neuroscience?
Totally, yes. As I said, I will briefly mention how neuroscience affects, how AI affected neuroscience research to begin with. First of all, like all the models and all the like neural network models, they have already been used a lot in how we process fMRI scans, how we process MT scans. So it is already being used highly. It's not a future thing. For instance, how we interpret the EEG um, recordings, like the the brain waves of humans, and detect, for instance, sleep disorders, detect epilepsy. So any kind of pattern recognition uh, is already included AI up until this moment. And also we see a lot of use of predictive modeling, for instance, how to combine the imaging data we have with the other clinical data, like the person's history, other diseases, like what is the average like diagnostic errors, etc. There are models being used, for instance, to predict the outcome, like the future of certain diseases. For instance, someone has a certain condition, and predicting around what time, what kind of therapies would be helpful, or what is the potential comorbidities, like potential other diseases, etc. So these it's also a very deep topic. There are already being used examples of AI, but also there are few areas that are right now getting more and more traction, with more powerful models can be developed and more like computing power we have. For instance, it's a really new effort to build individual therapy structures. So it's specific to a person. So they have all of your data, all of your, for instance, both CT scans, MRIs, your blood work details, and then they find the treatment that would be helpful most for you. So this kind of personal therapies are also, I think, we will see more, we will hear more about this, and they will be like thanks to good incorporation of AI. So it's, I think, if people are curious about it, they can like search terms like precision medicine. It will be, I think, the new healthcare movement, that like tailoring treatments for individual patients.
And do you know, can you better say, how do you can explain the association between multi-level programming, which is, I understand, is a base of AI, and how our brain works? Because a lot of people associate brain with programming, that our thoughts
Yes.
kind of programming language. Even based on that thing, there are many things like, I don't know, affirmations or different even psychological technologies. And so is it like, can you explain more about how does it really work, our brain, and is it same or not? What means is multi-level programming?
So, in the sense that like the similarities, for instance, the starting of the convolutional neural networks or deep neural networks having this hierarchy of systems has been influenced and inspired by the work done with the brain. So, for instance, how the vision works. We have a primary visual cortex. We first detect where is light, where is not. So it starts with the basic. And then on top of this layer, this information is being sent to more complex parts of the cortex. Then you do more complex analysis. You find the edges of images or like objects. And then this is sent to more complex areas, like more frontal, like is there a motion? What is the color? So it's this kind of layers of processing has been first found by neuroscience and neurology works. And this was the initial inspiration for developing these deep neural network models. So how are we going to incorporate different layers of information? Each layer is minimally encoding certain type of information, but with every layer, it gets more complex. So in this broad sense, it is very similar how this kind of multi-layer programming works and how the brain works. But of course, in principle, when we go to details, there are still many differences, because also there are so many things that we don't know about the brain, like how, for instance, certain like emotions impact the lower level levels. So it's not only bottom up information, but top down influences, and how is this balance when we give more information to bottom up information, and when do we give more weight to the top down, etc. So it's there are of course nuances there, but overall, yes, it is at least in principle, it is highly comparable.
And so, as I understand you, we associate this multi-level AI programming with kind of a tree in some cases. There is some main branch and there is a smaller branches, yes, and there is a layers by layers. But for me, this was new, and you say that this is how our brain in general works, but we have something on top, yes? Am I correct? What you're saying, that we have another type of scanner between the layers that help us to digest information, yes?
Yes, no, I meant like the 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 direction of the communication between these layers. For instance, when we think of a certain tree, like the main branch of the tree, and then the other branches, leaves, etc. So is it like that this lower branch is informing the upper branches and we get a general idea, or there is also information coming from the main branch back to down? And yes, there is, both things are in play, and also most of the current AI system use this, like the current like back propagation, for instance, as a general principle. So we both have from bottom to the up information, but from up to the bottom. But when it comes to AI, these are defined. The people who engineer these AI systems, they already know the how things connect to each other up to a certain level. But with brain, of course, there are still certain areas that it's not that clear. So we haven't made a brain yet, so to speak. But yes, these layers interact with each other and their direction changes. But when do we give more information to the information, like to the coming from up or down? This is a factor that is influenced by emotions, for example, or like other bodily states. For instance, even your heart rate can impact how you process certain information, how you hear, and your blood pressure. So for the brain, for the natural intelligence, things are more complex.
That's why, for example, level of stress so much affect how we think. Yeah. So if we are overstressed,
Yes,
sometimes it's hard to concentrate, and
exactly.
some simple things you would really struggle to do, which in normal condition and calm condition much easier to do for you.
Totally, definitely. Yes, it
So you can say that
impairs.
it's just a bunch of many signals which are going to these layers. And because in general there's so much signals, that the system kind of overdose. It's like if in Windows we open too many win. Oh,
Exactly. Yes, it's a good analogy actually. Yes, and stress usually gives that, but also like certain level of stress is good for thinking. When you're too low on stress, which means you're drowsy, you're falling asleep, which is also not good. So these are, but for AI, given a question, if given a chess play, it's not stressed. It just does. So these are the also the differences
so we
when we
can
think
say
about.
that chronic stress is very bad, but kind of meditative state, like I don't know, very calm, preserving it, but at the same time have some interaction with surroundings. It's good state and most efficient for the brain.
Yes, exactly. Yes, chronic stress is bad because in nature, like in when we see in animals, there's a stress full times. When you're running away from a predator, you have to stress. You cannot just be calm and zen out of it. You have to run. And but in the modern life right now, the level of stress, like feeling like it's like having meetings every day, having to prove yourself to someone every day, and this stress is not natural. This when it becomes a problem for the system.
When we talk about AI, AI sometimes make mistakes. Can you
Mhm.
explain this mechanism? How does it make mistakes, and how can we avoid that? For example, if we work with medical imaging, something most popular
Mhm.
in healthcare.
Yes, it is. It's a good question. Of course, with every predictive system or every pattern recognition algorithm, there's a there's a huge training phase, and based on this training data, models learn to predict certain things and associate. Okay, this dark part here in this imaging signifies this. Like maybe there's a tumor or things like that. But of course, training data sometimes is limited, and the model gets very highly fixed on this training data. We call this as overfitting. And then when you see different types of data, the predictive power like immediately lowers. You're like, oh my God, I trained this model, it was working perfect. What happened now? So this could be one of the reasons that AI makes mistakes. But right now, the good thing that's happening right now is that the computer power increased rapidly. Like all these new technologies um, is thanks to that. All these changes in the LLM and all. So by like we can leverage this by increasing the training data in a huge way. But of course, there will always be errors. But humans also make errors. So what matters is like what is the percentage of this. And with everything, like with any diagnosis and any like detection through an imaging or certain even surgeries, there's a certain prediction that you say that, okay, I make a diagnosis, this is my diagnosed illness for you within these confidence intervals. So with AI, what matters is, I guess, if this error rate is below or above the humans. And yeah, we have to also think about that, how much forgiving we are for the errors that AI makes versus a doctor makes, and also increasing the number. So thinking of AI as an alternative, like something that cooperates with humans, not that we give all the decisions to AI, but we we take one more opinion. So I don't think that AI will eliminate doctors or health professionals. It will just be something like an additional opinion.
Like if we talk about this example of medical imaging, MRIs
Mm-hmm.
and CT scans, can you explain how does it really valuable? Like what it gives doctor, for example, which doctor can't have itself? How does it improve the whole process?
Totally. First of all, there is limits of our visual system, that what we can detect in a certain image given in a certain screen. And also, as we mentioned, the human factor is a big thing. So AI has already been helpful, showing the search, at least like, hey, like warning doctors, hey, I detected some curious part here, take another look. So this kind of use has already been there. Or for instance, in EEG, in like finding the correlates of or detecting the quality of sleep, etc. From the initial day, there was always been AI algorithms. So it's not something new, and we need it. We cannot. We are good pattern detectors, but AI is like trained specifically on this is another level. We cannot train a human with um, 3 million fMRI images, but we can train AI. So this is the additional advantage of using AI, that it has seen more images than a typical doctor, and it has invaluable pattern detection capabilities. And also by cross-checking between different AI systems can be another tool helping the doctors. So, okay, instead of relying on one AI tool or one AI algorithm, having multiple of them and like cross-checking as if it's already been done with doctors. Okay, let's show this report or show this image to another doctor and get another opinion. So
Yeah, that's true. Nowadays in healthcare, there is a big tendency in most advanced clinics. So it's called shared decision making, when
yeah.
you really share your decision between different specialists, and not only specialists, but the patient, and you discuss together what should be the treatment for you, why this kind or why that kind, and this also helps the outcomes. And if we will invite few AIs in this team of shared decision making, for sure it can make a deal. Just sometimes people like being perfectionist, and they think I like only AI or like only doctor. Yes, but what about just holistic view that this can help? And even with AI, we don't like really totally rely on one AI, yeah, because there can be different AIs and they can be differently trained and they can use different
Mm-hmm.
story of this training, and that's why they have a bit different vision, which can really help us in general to minimize the risks.
Totally agree. I think in general, not only in health and uh, health setting, I think that should be our main and base idea of how AI will change our work and the world. Because I don't think we should imagine a future that AI comes and does human jobs, rather that it will be a shared setting, as you said. And especially in this case with health, it's highly important. It's not a field that we can take risks and leverage our health
Yes,
healthcare, like.
leverage our ego of humans being the perfect being and protecting the rights. No, maybe there is some social justice should be there and harmony should be there, but in
Mhm,
general, I think we should think more about really what is the main goal, and the main goal is
mhm,
being healthy, live longer. And if
exactly.
AI can support in this, then we should just use it and do it as fast as possible, because this is
Totally.
lifetime. Yes, it's most valuable thing. So, coming the next topic, what I wanted to discuss with you today, maybe I will feel childish, but I'm not really good in this topic. Is like human brain interface. What is that? And can you, like, I don't know, use this to speak with AI and I don't know, to do some things just with your brain or not? What is now the stage of development of this technology? Can you tell more about this? Very interesting. And is there any connection to AI between the
Of
neural
course.
interface and AI?
So basically, like the brain-computer interfaces is, as the name suggests, there is certain technology that you read the activity of the brain, and then you manipulate either an object or some sort of outside, like, or maybe a code or some computer with it. So, and this machine, this system can be for like transcribing words uh, for instance, ALS patients, or like to manipulate objects by robotic arms, etc. There are both like different types of this, and it's getting more and more refined versions coming up, with also thanks to updates and improvements in AI, and also like the robotics as well, that part as well. So, for instance, there are both invasive examples that you put a chip into the brain. For instance, the Neuralink of Meta, like, or Elon Musk is one example of it. Like, it's again a brain-computer interface, but there are already been examples of it. These are called invasive because it requires a surgery and putting actual chips. And there are also non-invasive ones, like maybe with reading the with electrodes through scalp, like with EEG models. These also have been used a lot because with EEG, you can, for instance, read signals that when someone wants to uh, move left or move right, these kind of potentials are relatively easier to read. And then you like use a certain like robotic arm with it, for example, or using virtual keyboards. Like, so up until now, like the brain computer interfaces that reads minds, like your thinking, is not yet being developed. But for instance, many patients for decades have already been using the versions that they think of a letter, like, or like they look at a certain part, like to the reflected keyboard, and they form words and sentences, and they communicate with it. And these are already huge advantages compared to, if we don't have these, for many people it will be like the communication goes to a halt. But of course, there are many challenges, and if you ask how AI changes this field, as I said, with all the benefits of AI in like finding patterns, applies to this. If we can understand from brain signal where someone wants to go, and then with the brain computer interface, we can just decode that information and make that movement like with the rest of the equipment, you know. So it is improving the use of BCIs, and also not just like uh, moving navigation, but as you said, reading the mental activity, understanding when people's attention goes lower, when people get stressed, or when people feel happy, or I don't know, like when you're in an attentive state. So there are also uses of BCI to enhance certain capabilities. So to think better, let's say, or to focus better, etc.
Yeah, just yesterday I wrote some newsletter about some guy who created AI himself just from laptop, that if you stop working, it starts to shout, "Hey, you need to work, don't be lazy." And
Yeah.
go out, he say, "Where do you go? Come back, work."
Yeah.
We're laughing, but still, it's quite amazing. Yes, that you can make it.
Yes,
The AI analyze your camera work, and after he gives you a comment what to do depending on that.
exactly. The question is
Um,
if it works, like if somebody yells at you, makes you motivates you or not.
true.
Yeah.
What are the risks of using AI to connect the brain with machines?
So in general, like the general risks of BCIs, brain computer interfaces, are like first ones are about the more physical side of it. So if it's an invasive type that you put a chip or like so it requires a surgery, there are risks involved with that. And also like if the body will accept this implant, etc. These are typical medical risks of these operations. But specifically with AI, what creates new risks is the potential of reading more like intentions of people, ideas of people, opinions. And then this also creates a certain risk of manipulating. Like if someone hacks these systems, they have a really deep personal information about you. It's like it's already a problem that if somebody like hacks your, for instance, healthcare records, it's already a big thing. And imagine if this system is hacked, they can see your whole data of which time in the day your like whatever part of brain is more active, more low, blah blah blah, and they can manipulate. They can use this to, I don't know, like for many malicious reasons, honestly. And also, yeah, these privacy risks also involves uh, additional ethical concerns about, um, for instance, like because there are also some systems that feed like has a feedback loop, not that just not manipulate outside world, but for instance, it also gives back a signal, so it also changes your body, like brain. So this is a loop. So you're no longer just a individual being, but you're also being impacted from this system. So these are like then, for instance, if somebody commits a crime within this like closed loop scenario, and like how to recognize what is the responsibility of these people, because maybe it's a combined being now with this system. So there are so many risks from coming from different angles, but the most common ones to think about are, yes, like the freedom and like, yes, privacy risks. What if someone hacks? What if companies start selling you things based on this, because they're already doing it with our data on applications, for example? What if you have one more channel of data, which is your brain? They know when you're more activated, when you're more impulsive, when you're going to buy something.
Yes, it's like sometimes you need 1 year of therapy to understand something of you, and here we know it is even better when you know yourself. Yes, because
Yes.
sometimes your consciousness is not so developed, yes, to really understand the meaning of all the signals that your body, your brain sends you. You need really a time of self-development and self-awareness to understand yourself, and this sometimes takes years. And with this type of device, it's and if this data can be used, it's so much yes option. Like, do you love Communist Party or something like that? And if you say
Exactly.
no, it means it's you have a problem. You need to go to specific educational program, yes, and so on. So like in
Yeah,
the horror movies about dictatorship. So
exactly.
what we come to the topic is that the more technologies are developed, the more ethical humanity should be, because the more instruments there is to manipulate each other, and same time this manipulation can be positive or negative. Um, I want to also ask you one question about the robotic limbs.
Hmm.
What we were talking about. How does AI help control robotic limbs for disabled people?
Yes, as I described briefly with brain computer interfaces, one big use was like, okay, yes, people who have lost a limb or paralyzed, like they cannot move. So how can we read the motor signal or like intentional signal from the brain that wants to move and then convert this signal into an actual motion of a robotic arm? So there are really good examples of this. So because reading motor information from brain is relatively easier than reading your opinion on the world state, for example. It is like, for instance, with event-related potentials through EEG, you can detect if someone is planning or intending to move their arms or their legs or their nose, etc. So converting this information through a robotic system, and so this allows patients to be able to interact with the world. Most of the examples we see with hand, like grasping objects, pointing, or there are examples with walking, either with like certain like chair type of situation or more complex robotic examples. So it is basically the main brain-computer interface, but of course there is also a huge part of robotics there that I am not an expert of. Yeah. So the question here has to be a real time and precise reading, because when we think of hand movements, one hand movement another, it's very similar to each other, but one cracks the egg, the other just holds it and carries it. So it has to be very precise. Therefore, it requires training. So most of the time, patients first they train to use this system. So the AI system here is learning how this person's neural signals correlate to movement, because with everybody it's different. This is the overall difficulty of BCI systems, that the individual differences in brain and brain activity requires a training for each individual person. So you train the model with your own behavior, and some systems this was like it requires like 100 hours of training, and others less, others more. So this is what AI helps here, like making this training process easier. So this helps more people, more accessible.
I want also little by little wrap out our discussion, just a few last questions. One of the ideas I want personally to hear your opinion. What do you think about AI for mental health? What I mean, not as a tool for support, but when we really have a therapist and when we have AI therapists. For example, even using the voice, because voices may be stronger effect, but still, is it really possible to do like a mental health therapy with a AI voice messaging or not? What is your opinion about that?
I am sure that like I hear and see this in the social media and in current media right now. Many people are already using AI systems to get counseling or suggestions or asking big questions. Hey, this is the situation. Help me. What should I do? And I think this shows that it's already showing some signs. And because therapy in many countries is not covered under healthcare and it's expensive, so even if it is helpful or not, people are going to go that road. And in some cases, actually, it can be helpful when somebody has no access to therapy, but through these systems. But of course, I'm not sure about the intricacies, because AI and especially these LLM systems, in many cases, depending on the prompts you give, it can keep you in a certain bubble. But therapy is not always that. So in some forms of therapy, the therapist challenges you or makes you see um, your main problems, etc. It's not just something that tells you you're right or like, yes, they're wrong. But of course, I'm sure there will be many specific applications in this. And I recently saw a therapist talking about this, and they were really positive about it, which made me feel good, because many of the therapists are like, no, only humans can do therapy. But I think it has real potential, because especially as you said with the voice, it is, yeah, maybe it cannot take place of the therapist, which I agree, because it's still a different thing talking to a human and knowing that it's a human than talking to something but it's not a real human. So I think we will see more nuanced examples of this.
Yes, also there is anyway nowadays therapy is really developing a new method. Are there, for example, I tried EMDMR method. It's method when you see you look
Mm-hmm.
specific, and the therapist was very experienced. When I was working with her, she was really nice, and as she told me, the main topic is that she should know where to use this instrument, because this instrument is really very powerful, but you can use it only in the specific moments. She kind of need
Yeah.
to catch my specific
Mm-hmm.
condition and then to use this technology to kind of update the
Yeah.
brain. And to really catch this, I, for example, don't really see that he can catch it because there are so many things. Maybe if you have the brain interface or something
Yeah.
similar, you can understand that and
Yeah.
this all this together, then maybe it will work. But how well it will be, maybe in 10 years. So
Maybe.
far, I think that AI maybe can affect your mood right now. For example, is you if you're really in bad condition, you start to speak, you will feel better. But if we want to have a long-term therapy effect, I think it's still very weak to do
Yeah.
that.
Yes,
And or
totally.
you need just a lot of time, and maybe with a real therapist, you can just do it faster. And nowadays, yes, time is super precious.
Yes, as you said, EMDR, for instance, is a very specific type of therapy, and I don't think a typical chatbot type of AI can take place of it, at least now. No, but also there are like a lot of types of psychotherapy. In some, that what matters, what brings the health effects, is the connection between the therapists. So, according to this field of psychotherapy, of course, they are all against that AI can anyway replace, because there is no therapist and client sort of interaction there. But
Yeah.
we will see. I think there are in certain ways it can help.
Mhm. As to wrap it up a bit, can you give some advice for those healthcare professionals, or maybe even tech professionals or business professionals who think of usage of AI for healthcare? Maybe you can give some advices how to do that better, or
Hmm.
but first of all, to consider some advices.
First of all, like for both healthcare professionals or any other like business area, I suggest people to keep up to date with the specific AI tools that are released or in their own field, both for their careers perspective, also to know maybe they can help their like their patients better, knowing about these tools. And in general, like if they are hesitant to use of AI in certain places, like challenging themselves, like it is not going to take their job, or it will be more like a cooperation with them. And it is already, and remembering that AI has already been used in healthcare for, like right now we think of AI like like these chatbots, but many algorithms of AI, like neural networks, or like many types of regression based models, classifications, diagnostic criteria, AI has already been used. Like acknowledging that, I think, will reduce people's resistance to it. Yeah, this
The
would
only
be
problem
my
is for
general.
designers. With the new version of ChatGPT, they are a bit in shock, yes, guys, but we support with you. You will do it.
Yeah.
Sorry.
Yeah. Yes, exactly. And I like, the point is like, yes, because if there is a method that will help you do your job better, help people better, why not do it? Because it will also give you an advantage against the other people, other professionals who don't use it. So,
Mhm. And maybe this small advice if I start my own project and I'm implementing AI, like I don't know,
mhm.
top three things to consider.
First of all, yes, if you're implementing AI, first of all, you need to make sure if Are we still talking about the healthcare field?
Yes, yes.
Or okay.
Mhm.
So first thing is that are there any other examples? Always good to know that if something is already being done before, like doing the benchmark or finding the similar tools, similar algorithms, because the AI part might require either using like third party tools, like or getting consultancy or buying a product from an AI company or developing your own AI. So making that decision is the second one. Second suggestion would be like if I'm getting help, who I will get help from, and then maybe trying to find like the benefit of it. What will be the benefit of this, and for me, and also for the patients, because there will be always the economical side, and you will have to justify this as well when if it's you that who makes these products to sell or to use or to I don't know or to buy from somewhere. So overall, these would be my general advices. Making sure if it already exists, making sure if I'm going to hire a team to do it or like buy a tool that already exists. And then what is the benefit? Yeah.
Okay. I think we are very good. Thank you so much. It was really interesting talk, and I think everyone understand the usage of AI, yes, the connection between brain interface and human and AI, and we kind of, I think, quite deeply discussed the general possibilities of AI. We breathe in, breathe out, understand that AI is part of life. We don't need to fight him. It's already happening. It's already part of our life, whatever we like it or we don't like it. But still, we should consider ethical moments because, yes, it's important. And in many cases, especially in the means of safety, the means of freedom, in the means of personality, yes, and we should consider that as well.
Yes.
Thank you so much. This was Devin Özbağcı, and she is a data scientist and doctor in neuroscience. Thank you so much.
Thank you so much for it was a really nice conversation. I enjoyed it.
Thank you. So please share this video if you know somebody who is working with AI in medicine. Maybe it can be really helpful just to save their time because it's quite short, but at the same time we have all the necessary information. And keep in touch. It was a Mental Growth Network podcast with Emi Under, digital health expert. Thank you so much. Bye bye.